Meow! My magnet sticks to the fridge so easily. Now let's try a banana. Thud! Wait, it just fell off. It didn't stick at all, kitty. In just 1 minute, we'll show you exactly why. We are even going to test a sneaky piece of metal that might surprise you. First, we need a closer look. Let's shrink down to bug size so we can see what is happening right here on the table. Look at this glowing bubble drawing on the screen. A magnet has an invisible push and pull area all around it. We call this a magnetic field. Because a magnet uses this invisible field instead of sticky glue, it does not grab everything. It follows very specific rules for what it pulls. Hannah, check out this diagram. Every magnet has two ends called poles, a north pole and a south pole. Ava, here is the rule. Opposite poles pull together. North and south snap into each other. But matching poles, like two norths, repel and shove each other away. Meow! Do you know why the two magnets stopped being friends? Because they were always on opposite poles about everything. Good one, kitty. A magnet's power comes from how these poles line up. That is what gives the invisible field the power to either hug things close or shove them away. Now we must learn the iron rule. Magnets do not stick to just any metal. They mostly only pull on things that have the metal iron inside of them. Let's test it. Watch this paperclip. Paperclips and spoons have iron inside. When they get close, they are pulled right into the magnetic field. This is why Kitty's banana trick failed. Bananas do not have iron. Neither do plastic cups or pieces of wood. No iron means no pull. But here is our sneaky test. What about aluminum foil? It is shiny and made of metal, so it should stick, right? Let's try. Nope, it falls right off. Not all metal is the same. Aluminum has no iron inside, so the magnet ignores it completely. This invisible field is very picky. If something does not have iron inside, the magnet just slides right past without pulling at all. Time for fun facts. Look at planet Earth. The whole Earth is actually a giant magnet with its very own north and south poles. This image shows a compass dial. The needle inside a compass is a tiny magnet, and it always points north because it is following Earth's giant magnetic field. Here is another one. This maglev train uses super strong magnets and the repelling rule to float heavy cars above tracks, zooming along without wheels. Look at this medical scanner. The largest magnets in hospitals are extremely powerful, requiring strict safety rules when doctors help sick people. These invisible fields work all over the world. They help sailors find the way home, keep fast trains floating, and even help doctors see inside our bodies to keep us healthy. Meow! Quiz time! Shout out the answers! Question 1. The invisible push and pull area around a magnet is called a magnetic what? Field. Question 2. Do two matching poles pull together or push apart? They push apart. Question 3. Does a magnet stick to a banana? Yes or no? No way. Great job. Remember, magnets use an invisible field. Opposite poles pull together, matching poles push apart, and they only grab things with iron inside. Try this trick with a grown-up today. Put a paperclip on top of a piece of paper. Then hide a magnet underneath the paper and move it around. Watch this diagram. A magnet's pull does not stop for non-magnetic things like paper. The invisible field reaches right through the paper to grab the iron paperclip, making it dance. Now you know the real science behind every magnet. Subscribe so you never miss a new adventure at Open Learning Lab. Keep exploring.